Hey guys, this is Jesse. Today we're going to assemble an entire FDL-2 Blaster. This assumes that you've either purchased an entire kit with all the 3D printed parts and electronics, or you've just purchased an electronics bundle and you've printed all of the pieces out and tapped all the holes and done any post-processing and touch-ups to any of the pieces that you've needed to do. The tools that you're going to need are a typical number 2 Phillips head screwdriver. I actually have two because there are a couple screws that it's nice to have a little bit of a longer screwdriver with. 2 Allen wrenches. One is a 1.5 millimeter Allen wrench, and the other one is a 3/32 of an inch Allen wrench. And then I have, this is a multi-tip screwdriver, but the purpose of this is really just to be a really small, thin, flathead screwdriver, and this is just to tighten down the knobs. And then I have a pair of needle nose pliers and also some wire cutters. The needle nose aren't entirely necessary, but it is nice to have them for grabbing stuff. And then the wire cutters we're going to use because this does involve using some zip ties to do some wire management and stuff. So real quick to go over what's in the kit here. So you have all your printed pieces in the back, everything from your magwell, your electronics cover, the pieces that make up your barrel, your kind of side plates, your handle, all that good stuff. And then the electronics kit, there are 3 different FDL PCBs. One goes in the kind of trigger handle assembly. The other one is what the particle photon goes in, and then the last one is what your stepper driver goes in, and then the stepper motor attaches to that. And then as far as the rest of the electronics, we have your microcontroller, which is your particle photon. You have your stepper driver, your 2 brushless motors, here's a voltmeter, your 2 ESCs, and then a number of different wiring harnesses over here, and your stepper motor there. And then to round it out, I've got a little bin with a bunch of the hardware, which is screws and stuff. And this is a mixture of different 632 machine screws, some 3mm hex head screws. There's some of these tiny, I think these are 2mm pan head screws that attach the flywheels to the brushless motors. And then there's a spring in here for your magwell. So let's get started. Alright, to start this off, let's work on building the barrel up front, which involves attaching the brushless motors, and then the flywheels onto them, and then attaching it to the magwell. So we'll start, grab a brushless motor, get your 3/32 Allen wrench, and you need 8 of these 3mm hex head screws. So if you orient the barrel here, you can tell where the kind of bigger flat side is, attaches onto the magwell. That will go like this. So you want to orient the wires back towards the rest of the blaster. There are actually openings in here, so you can feed your wires through those openings before screwing them in. So, and for reference too, the wire should point directly straight back, and that's kind of the easiest way to align the holes underneath. Alright, so what you're going to want to do is get all 4 of them very lightly screwed down. And then once you get them all gently screwed in, then you can tighten them down. You want to get them somewhere between hand tight and hand snug. I mean, these are screwing into the metal of the motors, but you don't want to ruin the motors, so you don't want to tighten them too much, but you do want them to really hold the motor in place. The thing's going to be spinning and vibrating all over the place. Alright, and then same thing on the other side. And again, once you get them all loosely in place, tighten them down. Alright, so we got both of the motors on. Now let's get the flywheels on top of each motor. Alright, so to attach the flywheels, we're going to use 8 of these little tiny flathead, I believe they're 2mm hex head screws. So you'll see the flywheels have a little bit of a cup to them. The motors actually fit down inside of that cup. And you kind of just have to turn the flywheel and see and match up the holes of the motor on the inside. And again, get each of these kind of loosely tightened, and you can go through and tighten each one later. So these little screws, you do want to be really careful tightening them because they are such a tiny head. It's easy to strip out where the Allen wrench actually goes into them. Alright, so next we're going to take the barrel and the flywheel assembly and attach it to the magwell piece. So there are holes right here that are right over the kind of angled section on the magwell that mate up to these holes on the barrel. So you want to feed the wires from the motors through those holes and then attach on the other side. Okay, so then the barrel attaches to here with 4 3/8 machine screws. This is actually the spot that I really like to use the longer screwdriver. You get a little better of an angle. Alright, so now I'm going to tighten these down, and this is kind of a major notice for the entire FDL. Just about anything that's 3D printed with screws screwing into it, you don't want to over tighten these because there is the potential of stripping out the hole. So just get them kind of like hand snug. The plastic will actually hold the screws in place really well. Alright, so we got your magwell and the barrel on the front. So let's work on actually putting the mag latch together and get it in the magwell. So you have these 3 small pieces that make up the mag release. You have this kind of block piece that slides into the magwell, and then you have the catch piece, and then you have the kind of little post, which is the button underneath the blaster. And then you have this small spring. So if you take your block, there's actually a cylindrical opening in here that accepts the spring. So kind of slide the spring down in there. Alright, so take your Allen wrench and then use it to compress that spring and kind of hold it in place. And then you take the assembly of the post and the catch and you put it in, and then you can let go of the Allen wrench. Now once that's together, you should be able to push the button on the bottom and everything should move nice and smooth. If some of this doesn't move smooth, you can kind of sand some of the edges a little bit and loosen it up a little bit. You do have the option of using a little bit of like white lithium or silicone grease in there just to give it a little bit of a smoother action. It just depends on how easy it works once you get it together. Alright, so then this whole piece should just slide right into the magwell. And then you use 2 1-inch 632 machine screws from this side, and they should slide all the way through that block. Alright, once you get that in place, you can kind of test fit it. There's the mag, should slide in pretty easily, and then click into place, and then you should be able to click the button and pull the mag out. There you go. Alright, so next up we're going to attach this kind of L-shaped piece, and this basically guides the pusher and prevents it from wiggling too far left and right, up and down. It gives it something to kind of ride along. So this particular piece, if you take your battery connection, there's actually holes and slots in here that guide the wires from the battery connection. And then there's also a hole in here that accepts the power switch. So on the power switch, there's an O and a line. The line is on. You want when you switch the blaster on, you want to be pushing the switch towards the front of the blaster. I mean, you can put it the other way around. It's kind of up to you. I just like to push forward to turn it on. So if we were to orient this like this, your line is going to be up front, and you should be able to just press the power switch into place and it'll stay there. Alright, so once you get your power switch in, you can run your battery cable through there. So the red wire of the battery connection goes on the same side that the power switch does. So you feed that through, feed the black wire through the other side, and then use the kind of channels in the piece to hold the wires into place. And then the whole thing will go onto the mag well like that. And then this is put in place with 4 1/2-inch 632 screws. Alright, so the way that this works is that you should be able to pull on the battery cable, and if you need it a little tight, a little longer, or a little shorter, you can actually make some kind of fine-tune adjustments, and it all depends on how long the cable is that comes from your LiPo battery. Alright, so next up we are going to work on building the wire bundle that sits above the pusher here. The bundle consists of the ESCs that connect up to the motors and also the power connections to the battery. So admittedly, this is probably one of the more difficult parts of the build. If you've ever built like an RC car or like a drone or something, you may be kind of familiar with having to do some cable management. If you haven't, then this may be a little tricky, but it is a good thing to know. If you look at your ESCs, off one side of the ESC there are 3 almost identical but different color leads. Those go to each of the brushless motors. On the opposite side of the ESC there is a red cable and a black cable. Those connect directly to the battery, in this case with the power switch in between. And then there's a third connection that's this brown, red, and like yellow or orange cable, and that connects back to the particle photon. The brown and the red are a 5-volt connection that actually power the photon. The ESCs have a voltage regulator in them that will take the battery power and convert it to power usable by the microcontroller. And then the orange wire on this is the data connection back and forth that will actually control the speed of the motors. So what we're going to do is we're going to start building a little bit of this bundle out. So I'm going to grab the 2 ESCs. I'm going to grab the power harness, which is this kind of harness of red and black wire. So at the end of the 2 main connections there are these 2 Ys with 2mm bullet connections on either side. So go ahead and hook up the power, the main power from each of the ESCs to one spot on each side of the Y. Black goes to black, red goes to red. And then you end up something that looks a little like this. And then what you're going to want to do, grab a bundle of zip ties. And what we're going to do is kind of iteratively build this bundle. So we'll bundle up a little bit of it, put a zip tie on there, build a little more, and then keep going from there. Take the power wires on one of the ESCs, bend them to one side, and then bend them back. And then the other ESC, you want to go on the other side. And something I forgot to mention too, you want the stickers facing out. That side of the ESC actually has all of the MOSFETs on it, and those are what's going to get a little warm on the ESC, so you want them to go outside so they can stay cool. And then when you build the bundle, you want the motor leads of each of the ESCs to be opposite one another. So what's going to happen is the leads for one motor are going to go down one side of the barrel, and the leads from the other ESC are going to go down the other side. So you kind of fill up the space in between the two ESCs, and then take the zip tie, and then zip tie this little kind of sandwich that you've made together. Don't tighten the zip tie too hard. You don't want to destroy any of the electronics on there or tug on any of the wires too much. You just want to kind of hold it in place so that it doesn't go anywhere. Then we'll put that down for a second. If we take what we've assembled so far, you have this red lead hanging out, which connects to the power switch. You can go ahead and connect that now. It's a pretty tight connection, which is a good thing because you don't want your main power leads coming unplugged. Then you're going to take your bundle and slide the leads for the motors through the openings in the chassis here. So you should be able to easily put all three through and have them come out the other side of here. And once they're out the other side, you can grab them and connect your motor leads. At this point in time, it doesn't matter which motor lead goes into the ESC wire. Later on, when we boot the blaster up, we'll see which way the motors are spinning, and if they're spinning in the wrong direction, all you have to do is switch two of the motor leads with the ESC leads, and it'll spin the motor the opposite direction. Okay, so then on the other side, we want to pull that back through a little bit, and then feed the motor leads from the other ESC through that same opening on the other side. And then once they get through, you can grab them, and then again, connect each of the three leads to the ESC in any spot for now. And then go ahead and pull those wires all the way through. And your bundle starts looking a little bit like that. There is the black wire that comes from the battery connection that has the 3.5mm bullet connector on it. On one end of the power harness, there is the connector that goes into that. And then the red connector goes on the other side of the power switch. So the power switch actually kills all power to the blaster. There you go. Now, once you get that in, we can start bundling up the power wires too. There you go. Okay, so you are still left with a couple more power connections and then your two ESC lines that go back to the microcontroller. There is another wire harness that connects to the ESCs and then carries that back to the particle photon. This is a red, black, and orange wire that matches the same wires from the ESCs. So make sure that you match the same colors from the ESCs into this wire harness. At the very least, black and brown should match on either side. Then you can feed another zip tie through there and bundle this same thing up. And then you can remove the previous zip tie. There you go. It's not too bad. So the key here is to get your bundle tight enough so that it all fits within the width of the electrical cover. But again, don't bundle it up so tight that you're going to damage the ESCs or you're going to like really hard bend any of the wires. This is high strand silicon wire, so it does bend really easily, but you just don't want to do it too hard. Alright, so we got that in place. Now we can start building out the back of the blaster and it will slide into the front.